Hello and welcome everyone.
Oh, that's it.
No, that's not. Yeah, so it's Bernhard, Ernst, and Daniel, and we welcome you to the second edition of SeatedVR workshop. Yay! This year with this little addition you might have noticed, embodiment. Where does this come from? And the answer to this is twofold. So last year we discussed key challenges and questions of SeatedVR, and we wanted to give it another color. We wanted to add something. And the second thing is already last year in the discussion and especially after the workshop in the work that followed, we discovered that embodiment plays a key role when users are passively sitting and waiting to be entertained. And that's the reason for the addition. So we, by design, left out what we explicitly mean with embodiment, because I think there are a lot of definitions out there, and we left it open for discussion in this workshop. Also already last year, we planned to have a very interactive workshop, and I think we had, but we wanted also to use a lot of colored pencils, sticky notes, and stuff like that. And as you know, there was something in between that. We spontaneously had to change everything and made everything possible to still keep it interactive, but it was different than planned. Let's say it like that. So this year, we are still in quarantine somehow, but we had more time to prepare, and sticky notes are back. They are still virtual, as you will see, but yeah, they are back. So let's make the best out of it. Let's have some fun. Let's discuss. Let's socialize. Let's fight bad mood and COVID. For this, our main platform will Miro today, and Bernhard will find some introductory notes on that one.
Yeah, thanks, Daniel. Yeah, so the goal is really to not have you asked to listen to 20 more talks. So we will have a few talks, but we keep them fairly short. So we have a lot more time for discussion, interaction, and not quite embodiment, because that's still a bit hard. But yeah, the main goal is really to have a lot of conversations in there. So here's the overall board, and I'll guide you basically through this. So before the break, we'll basically do the introductions, listen to the talks, and then start the group work. And after the break, we'll go a lot more into the group work, and we'll let you know all about the details there. All right, so want to give a brief introduction to Miro. Actually, who has used Miro before? That's online whiteboard. Just raise your hand if you're virtual or something like that. Okay, a few people. That's totally fine. So it's basically an online whiteboard. As an educator, you can actually get a free license, which is kind of nice. So what you have, basically, you can log in with the browser or not. We posted the link on Discord. So basically, if you go to the Discord server, you can log in there directly. You don't need to do this yet, but maybe in the next few minutes, try and do that, because we'll do our introductions there. And as usual, let us know on Discord if you have any problems. So we decided to basically, for any feedback, don't use the Zoom chat. That's harder to keep track of. Just use the Discord server. We're workshop 2 here. All right. So a quick introduction to Miro. The way I arranged this, so basically there's various things. At the bottom, you have this little thing that you can expand and collapse. The way I arranged it is through frames. What that basically means, there's different frames, and this gives me the overview, and we kind of go from top to bottom. Here's the introduction, here's the next overview. So you can use this if you ever get lost, which can happen. So you can basically zoom in, zoom out with your scroll wheel, and it's basically almost like an infinite zoom that you can do. If you ever get lost, you can also, at the bottom right here, use this to navigate around, which can be quite useful. Sometimes we have aspects where we ask you to give feedback. That's basically on, so for example here, just take your key, move it down there, and start typing. Oops, I need to double click. And if it's too small, you just enter it there. And as you see, basically, no matter how much, it should be relatively easy and straightforward, I hope. So again, if you're ever lost, you can just click on the left side here. If you don't see the frames thing, that's where it is. The only other thing you might need is if you need more sticky notes, or later on when we ask you to go into breakout rooms, you can add more sticky notes here. You can pick your favorite color and add your note here. Keep in mind, everything is scalable to a huge amount. So typically, sometimes it starts way too big. Then I think that's kind of the main thing you'll need. So what we'll do in the next part is basically, let me see whether I'm missing anything. I have these parts. Oh yeah. Most of you are, I'm sure, familiar with this. So if you have a dual monitor setup for Zoom in the settings, it's a lot easier if you click on use dual monitors. Then you can see both the people, like for example, me. If I look to this side, I actually see you, ironically, because my camera is on top of the screen that I'm sharing, but then that'll be a bit easier. Here's some more information on Miro if you ever need that, but I think it should be okay. So what we'd like to do now as an introduction is ask you basically each to fill out the information here. So I'll just do this and I'll take the liberty of doing this for Daniel. So basically, if you have the information there already, so for example, Daniel gave me a picture of himself, or no, picture of where he lives, then I can just add this here, drop it. What happens then, it takes a moment to load it up, and typically it's way too big. Don't ask me why Miro does that, so you kind of need to squeeze it in. But we figured that this way we have a much easier way of seeing where everything is. The other thing you can do is you can also just use Google image search, and let's see. Sure whether I typed this correctly. So I could, for example, just include Daniel's picture from there, so I don't need to upload it. It should just appear here, although there was some error message, not sure what that meant. Maybe I wasn't allowed to use this. Let's use another image here of his chair. Let's see. Okay. Again,
you're finding this chair when you Google my name?
Yes.
Oh no.
Don't ask me why.
Fourth hit. Fourth hit.
Yeah. And other things we were interested, if you like and have time for a moment, maybe just mention one fun fact. You can either just, directly zoom in there and add text, or if you have an interesting picture, you can just also upload that. And again, it looks like it'll make it way too large. So then you might need to explain the shooting part and how that relates to sitting in VR.
It does not, but it's something not everybody knows about me.
Okay. And here's an image I'm doing VR. So basically, that was the idea, because we have a lot of people in there. And this way, you also can relate and basically connect with people later on. And we'll do group work, so I think it might be useful. So if you can do that. If you want to select things, if you press Shift and then select an area, then you can also start grouping it, which can also help, because then you can move it together if you want. That just makes it a bit easier. So yeah, just play around with that, maybe the next minute or two. Sometimes I'll give you guys timers. So let's just say we do this in 2 minutes, and just see how far you get. At the least, try and put in your name. So pick one object, and then for everybody who's already done this, you can just kind of zoom around here. One thing you notice, so by clicking and dragging, you can do this. If you click and drag on an object, you just move that object. So that's probably not what you want. So just click outside on the frame and so on, then you can move this around. And again, if you're ever lost, you can down here, move around, or just click back on a frame here. All right, let's do that. And
yeah, even if you don't want to share any pictures or something like that, feel free to add your name so we can put you in groups later on the board. Yeah.
Yes. And okay, Gerd, I think you'll need to explain the riding the alligator part. And as usual with these kind of things, we might be kind of busy presenting and things like that. So if ever something's not working, you can't hear us, or just unmute yourself and talk directly, because it might take a while until we listen to the Discord chat. All right, so suggestion is to just kind of look around who's there, see who you might know already. Things you might not have known about people. Ooh, there's more alligators. Uh-oh. Also, in case you notice, so basically wherever you point your mouse, if you zoom in, then you can see people there. And you can continue uploading your pictures while we move forward with that. All right, so again, take some more time to add things, look around who's there. In the meantime, we'll continue with the goals of the workshop. And I think, Daniel, you wanted to take on that part, right?
Yeah, just shortly, because some of them were already mentioned implicitly. I think, yeah, the goals of that workshop are manifold, and you might have even others. Just let us know. Of course, we are doing this for networking. We want to do that for having some fun. And that's why we try to make it interactive. We want to meet and talk with people that might have shared interests. Maybe there's room even for starting new interesting projects, as there were some starting last year. Yeah, foster connections and collaborations is something related. We also, of course, want to hear about your late-breaking work, and we will see some of it in the talks. Yeah, overall, we want to work together in this workshop. That's the overall goal of it, and you might have already noticed that. Yeah, so that's it about the why.
You want to go over the rules of play? I mean, it's basically fairly simple. We will be using Miro as the main tool, and Zoom, as you know. For feedback, we often have specific stickies put on the board. We'll point these out. For anything else, just use the Discord channel, the workshop 2. You might need to scroll way down because it's a long list of channels. We'll do one main break in the middle. So as usual, whatever, feel free to take your own breaks, bring your own beer, drinks, whatever. There's no alcohol license for the Zoom event, but you can do whatever you want in your own place. This one big advantage. I think that's it. Anything missing, Daniel, in terms of organization?
Nope, I don't think so.
All right, then over to you, Daniel, for the report from what we did last year.
Yeah, there was the first workshop. We talked about that as well. And we just want to report some things that went over after the workshop, how it continued. Last year, Bernard and I, we had this try of a classification regarding advantages and disadvantages of sitting and standing. We discussed this topic actively on the workshop. It was really interesting. We got a lot out of that. From that moment on, we worked on that. We changed a lot, made it more interesting, and yeah, we worked a lot on it. It's not finished, but it will go into review process next week, hopefully, and then you might get a read of all the stuff. Here's just some priming. Really connected to that one is the locomotion survey we started last fall, I think late fall. You might have heard about it. When you are an expert or have interest in a locomotion, maybe take part. You can win an enormous amount of Canadian money. Yeah, we put the link here, and it all somehow originated from this classification we started. Another thing, which is a little bit more unrelated, and Bernhard, you maybe can start the video that I've attached, is
just give me a sec. I just noticed that this link is not working because there is a full stop in here. So let me just fix that link.
Yeah, sure.
Because otherwise you guys can't click on the link. By the way, so in case you're using Miro boards, you can lock things. You can lock different objects, which can be quite useful because otherwise people can just move around too much. So let's just put this link in again. Now it should be working. And then if you lock it, then people can't move around. And that just wanted to. Okay, so that's the actual survey. All right, good. And the last part, after main discussions with Daniel, Ernst, and I, well, I think, Danny, you should introduce this one.
Yeah, no problem. Yeah, we discussed also one really important point when it comes to sitting and embodiment, which is the affordance of embodied interfaces or embodied locomotion interfaces. And thus we started in this little break of COVID where it was possible, at least here, to visit people. We started to introduce people that never have used VR before, or a controller or anything, to put them into an experience without any introduction or any thing else, as for instance here in this little task there, they just we just told them to try to follow the dragon, and then they had interfaces and they had no knowledge about the interfaces, and they first of all had to find out how to travel at all, or that they can move, which was not that easy. And one thing, yeah, just some random pictures here. One thing that's pretty interesting is when you don't, we really found out a lot of interesting thing there, and we hope that we can continue this work. And when you're not telling the people to move, one thing really interesting with this person, for instance, was at the end she found out how to move, but her impression actually was that she is moving the dragon and not moving herself. And the only way this was possible to observe this was because we were never telling her that she's moving herself. When we of course introduce her into something like that. Okay, I'm already going far beyond what I wanted to say, so let's stop here. There's a lot of interesting stuff going on there. Yeah, that's some of the projects and ideas we started right after or with the workshop. And maybe there are more interesting things after that one.
Yeah. And as you can imagine, so we're currently working on a paper on that because it's super interesting. People talk a lot about affordances, but so we really wanted to actually test what the affordance is. All right, so to get us started, what we wanted to do is ask you, so this is where I hope you're all on Miro already. So I see 22 people or so already. So just a quick questions like, okay, which aspects do you really miss most in virtual reality, especially in the concept of real-world locomotion and embodiment? So basically, just take a sticky, claim it by just moving it down there, and then zoom in and start typing. All right, yeah, that's it. So again, the link is on Discord. And you can put in multiple stickies, of course.
Do we maybe want to start a timer for this?
Oh yeah, good point. Let's do a timer, maybe 2 minutes, and up tempo funk after 2 minutes. Thanks.
If you like, we can even have a little bit more time on that because we are perfectly in time. I don't know.
Oh, excellent. Good. Okay, after the 2 minutes. And if you see similar topics, feel free to just kind of start moving them around. For example, oh, walking, strafing, there's some overlap. There's something about tracking. And you can add multiple parts. Okay, so maybe take another minute and look a bit around and see what's missing. And everybody feel free to start helping to structure and organize the topics a little bit already. So I'll give us another minute for that. All right. So what I'd like to do now is for us to use a voting, basically. So I'll set up a voting session. You can also do this. Basically, so everybody gets 2 minutes. You get up to 5 votes, and this is just for you to look at the other ones, and then you can upvote. Basically, select the ones that you like to get. You get 5 votes. I'll start it now. Should still be able to see this. So basically, you can click off any of these that you think. You can zoom in and zoom out. And you're like, oh, okay. If you like this one, then I'll add this. And you can do up to 5, basically. And if you think, okay, this is really so important, then you can put multiple votes there. All right, so do this. And I'll give you a minute or two to do this, and then we can use this also to see what kind of topics we'd really like to go more into.
Done. I want to have a cookie.
Okay, there's 40 minutes left.
See you all. I'm going to go to sleep. Sorry about that.
Jenny did want more upbeat music.
I'm crashing. No, it's not you, it's me.
Okay.
Good luck, Rob.
Yes.
Yeah, see you.
Hopefully see you
guys.
later. Get some sleep.
Take care.
Take care. All right. Let's see the results. Somehow I think I clicked this away accidentally. No. Sorry. Okay. All right. So basically what Miro gives you here, that's one of the reasons why we want to use it, is it gives you basically a list of the order. So it looks like we have 2 key parts, so really not getting sick, anything related to cyber sickness. And interestingly, a lot of people are interested in the transition in between walking and running. Haptics is also missing, full body tracking, not being able to touch anything, transitions in and out of VR. And then there's a lot of other topics like walking, non-intrusive hardware, being able to jump, and somehow the intersection between real and virtual worlds, and a lot more other interesting topics. All right, good. So let me go back to where we are. Daniel, do you have any final words on this part?
Nope, not so.
Okay, good. So I think we're pretty much on track with our timing, which is absolutely fascinating. So thanks all. So what we'd like to do next is go over the different talks. So we have 5 talks lined up. If ever, so we'll live stream them. If ever that live stream doesn't work for you guys, you can also click directly on this and watch it there. And what we'd like you to do is basically, as you're watching it, you just add comments in here. So not on Discord, just to keep it here, basically. So you should be able to just edit any of these directly. As usual, just pick one for any questions, and then the speaker or the video presenter can already start thinking and looking about this and getting a bit ready for that. And then maybe also do a super quick voting in terms of which questions we want the speaker to respond to. And I think we have, how much time do we have? I think about 4 minutes for discussion. It's roughly 3 to 4 minutes that we have planned. All right, I'll stop screen sharing so Daniel can share the videos locally.
Yes, I'll do so. So yeah, we have very short talks, 5 minutes each, and then, as Bernard said, a 5-minute Q&A session for everyone. So let me introduce the first talk. The topic is multisensory locomotion for SeatedVR. It's one of 2 invited talks, which means there was an abstract and as a talk, and there's no publication, and it's just a talk that's interesting. There are also 3 short papers on this session, and yeah, I will just shortly introduce if it's a talk or a short paper. So that's the first one. It's from Francesco Soave, which is here, I think so. Ildar Farkatdinov, sorry for when not pronouncing that correctly, and Nick Brian Kins. So they take you away.
Hello everyone, my name is Francesco Soave. I'm a PhD candidate at the Media and Arts Technology Centre at Queen Mary University of London. My research is about haptics, sound, virtual reality and motion perception. and today I'm here to present multisensory locomotion for SeatedVR. Existing research on movement in virtual reality usually is focused on two different aspects. On one hand, we have studies on locomotion, which focus on the implementation on technologies and methods on how we move in the virtual environment. So different taxonomies, comparisons on how fast you can reach a certain point, or the user experience of walking or flying or using a treadmill to run. On the other hand, we have perceptual studies which focus on the perception of motion, the perception of movement, like vection, which is also known as the illusion of self-motion, and motion sickness, and how all these influence presence. In our research, we focus on the perception of motion, but we also focus on haptic feedback. In particular, we are interested in the concept of whole body haptics. This concept is particularly interesting and comes from research that has nothing to do with virtual reality. It comes from research that studies the experience of music and how haptics can influence the experience of music. So researchers created seated platforms with actuators that vibrate according to a specific music, and then they study how the vibration influenced the experience of the music, basically. So haptics is coherent with sound, and it's about, again, user experience. To briefly describe our setup, so what we want to do is to explore the role of haptic feedback and vibrotactile feedback in the experience of motion in virtual reality. Our system uses 8 vibrotactile actuators on the seat and the back of a chair, and we use voice coil, Lofelt L5, and it's a SeatedVR experience, and it's a multisensory application. We use the sound of the virtual scene to drive the actuators, so we do not design predefined patterns of vibration. Some discussion topics that we are really interested into and that fits the workshop are, well, first of all, we are interested in identifying a framework for designing locomotion specifically for SeatedVR and how it differs from experiences that are not seated. So standing VR, wearable applications, for example, when it comes to locomotion. Second, investigate the benefits and limitations of applying haptic stimuli to applications that are not gaming, there are no games. So work-related applications, for example, in virtual reality. And third, we are interested in exploring the potential and drawbacks of action and illusion of motion in non-gaming SeatedVR applications. So thank you for watching, and please feel free to share any questions or ideas you might have.
Yeah, thank you for the interesting talk. I bring up the Miro board again, and let's see if we have some questions there. There seems to be something going on.
Given that we don't have a lot of questions yet, might just be the easiest to just, Francesco, to start just answering them as they come in. Or if you like, you can also unmute yourself.
Yeah, of course. So I might have a first question. It is, so I saw all the sensors and actuators looking quite interesting. What is the kind of motion you want to simulate? Is something is obvious and I think pretty interesting as this train, and I think that makes a lot of sense. But do you have any plans to try people to mimic, for instance, walking or something like that as well? Might that work? Is that an idea, or is that completely nonsense?
Hi, everyone.
Hi.
So since the beginning, we haven't focused on walking specifically. That, of course, is a possibility. Unfortunately, we only managed to run a preliminary study with our setups before COVID happened. And of course, all the research with the hardware had to stop. Right now, the plan for the future is to run a user study to observe speed variations that are randomly generated, basically, and to actually measure the involuntary body response. And also at the same time, we are planning to ask participants to rate their speed using a joystick and see if what they rate is also reflected in the same way on the involuntary movement. So that's what we're planning for the future. But we haven't specifically focused on walking, but of course that's also an interesting aspect.
So another question that came up is about the type of haptics cues, and some people wondering whether you could tell us a bit more about the haptics in there.
Okay, so we use vibrotactile feedback. So the haptic cues has been usually a continuous vibration, which changes in intensity and frequency, since it was connected with the sound of the virtual scene, which was the sound of the train going, basically. And now we are trying, so I mentioned in the presentation some whole body haptics user studies that comes from research on music and haptic feedback. And they did the research by applying different types of filtering to the soundtrack to turn the sound into the haptics mappings. And so we are planning to do something similar to explore different types of mappings between the sound of the scene and the vibration. But the idea is that it will be a continuous vibration, basically. And the reason for that is that our research, the approach is that we are thinking about a sort of real scenario. When you're a train, usually or when you're moving, there's always a sort of vibration ongoing. So it's not like stop and go, basically. I don't know if that gives enough detail.
Yeah. There was another question regarding, okay, whether or how you think these cues might help to reduce cyber sickness. Yeah. If you can answer that in 33 seconds.
Yeah, so I think there is a bit of literature on like Vection, haptics, and cyber sickness. We didn't focus on cyber sickness since the beginning because there were some ethical concerns on how we structure our user studies. But there seems, it might be, there is some promising literature on it. So we haven't focused on that, so I don't have an answer, but it might be.
Right, thanks. All right, so we'll try and time it fairly well, or fairly strictly, so we can make sure everybody has enough time to get questions and answer them, and we have time for the break. Daniel, do you want to briefly introduce the next one?
Of course. Yeah, when you have follow-up questions, feel free the whole time to put them under that talk, right? So that they can come back later and answer something or whatever. So yeah, second talk. Let's start that one. So I'm pausing it. So it's from it's an ankle-actuated seated-VR locomotion interface. That one is a short paper from Atan Otaran and Ilda Fakhatinov. Yeah, have fun.
Hello, I'm Ata, and I will present you our ankle-actuated and seated VR locomotion interface. Plenty of interfaces are available for enabling locomotion in VR, and some of these are joysticks, point and teleport methods, redirection methods, repositioning systems like treadmills, walking in place type systems like stepping in place or arm swinging. And there are many other methods and interfaces, as they were also presented in the workshop website. And all of such interfaces try to optimize locomotion experience by alleviating sensory conflicts, which may cause disorientation and motion sickness, or lowering space and cost requirements, providing a safe and stable body posture, and making the locomotion application feel more natural. We have developed a seated and hands-free interface that is driven by foot tapping movements done on a impedance-controlled platform. The oscillations of the platform are recognized as steps and used to simulate walking in VR. And we use plantar flexion and dorsiflexion movement of the foot, since it is a part of walking, and this movement is used extensively to help with seated and manually intensive tasks like driving, steering, or playing the piano. We actively control the impedance of the platform to study how we can deliver terrain-related feedback. And the interface requires smaller space, lower cost, and less time to prepare compared to many other systems out there. So during the foot tapping movements, we get such an oscillatory platform angle, and our algorithm recognizes each steps and provides a step phase data rather than just forward velocity data for the avatar, so that we can utilize readily available human-like avatars and walking animations. We believe that this may improve the sense of body ownership that the user feels. Since we use a single platform, the users should perform a fluent load transfer between left and right foot, just like they would do when they are normally walking between their legs. When the user were not able to synchronize their foot movements, we have seen these intermediate stopping regions while the platform is tilting up or down. In our experiments where we ask the users to just walk straight for a specific path, we have seen that these gesture errors were quite common at the beginning, but as the users got used to the interface, the performance improved and stabilized, and also users tended to increase their overall walking speed as they got more used to it. We are studying how we can utilize impedance controller for the terrain feedback. This may be done by simply changing the overall stiffness of the platform or using different multi-layered ground materials, the modules, I mean. Another experiment that we carried out was to see how well users could distinguish between 3 different terrains while walking on them. These terrains included one that had a single spring and damper system, and another one with a softer spring layer on top of the regular one, and another one with a stack of layers which would break one after the other after a certain amount of strain. So we had promising results, as you could see on the confusion matrix, and we are working on further improvements. Lastly, we are working on improving the method we use for steering to minimize motion sickness. Since the user's body should face the direction of the platform at all times, the users cannot basically turn around. So we are currently using upper body inclination angle commands to command the steering. But there are, of course, other methods, like for instance, using a joystick to command the steering, or foot sweeping, or some manual gestures maybe. And we are actually planning to do more research on this, and I would be happy to hear your suggestions on this topic as well. And maybe we can use additional vestibular system stimulation or any other methods. And thank you for listening. I'll be happy to hear any of your questions or comments. Thank you.
Thank you for the talk. There are questions coming up. I see them.
Hello, can you hear me?
We can hear you.
Yes.
Okay. Should I go through the questions, or do you want me to?
You can just directly go through the questions and pick them. It's not that many, so it's probably okay. Give you 4 minutes.
Mm-hmm. So why the mirror? I would say we wanted the users to see themselves and like see that their legs are moving, because we didn't want the users to be just looking at their legs while they are walking. So we want them to see the mirror and see how their motion relates to what they see in the mirror. Other than that, for fatigue, we didn't really do a test, but we asked the users, because we did experiments one after the other. We asked the users if they wanted to rest. They didn't say that they required to rest. After all the experiments, we did ask them about fatigue. They did give different answers, but it didn't show that they particularly had fatigue. We don't really know how much they should do in order to, like, before they get fatigue. That's right. Well, we can't understand at the moment if the user is stepping with left or right, and you don't have to step with either of them. Like, yeah, you can just use your right foot as well, but with left and right, you have a better sense of walking. Any measures of cognition? We will actually work on this. This is one of our feature works, because we also want to see how much, like how well they can, the users can use the manual interfaces along with the locomotion interface that we have built. But we have not really gone into the cognitive load side much. Why a robot avatar? Because Unity had it for free, and that's the first one I found for free. But it should work with any avatar rig, any humanoid avatar rig. We have not yet compared it to other interfaces. That is also a very important feature work that we should work on. Especially like standing interfaces. Can you predict change? Yeah, the step length at the moment is proportionally related to the stepping frequency. There has been some works on how the stepping length is related to the stepping frequency, and we used the previous results that were found in that topic. And am I missing any other questions? Or do you have any other questions? Or anything I couldn't explain now?
Well, it looks like everything was clear. So nice work, excellent paper. So we forgot to do virtual applause. So feel free to unmute yourself or wave your virtual hands. Yeah. So thanks again. And some people ask on Discord. Yes, the Miro board with all the links and so on will be available later on. I'll probably take off the edit rights just so it doesn't get accidentally scrambled or anything like that. But yes, we'll leave this online as a reference.
Yes. And there was also the question I saw with a blink of an eye or in my peripherals where you can find the papers. They are in the proceedings, which are out, I think. When the proceedings are online, they will also be linked to the website. Yeah. So that brings us to the next talk. Let me start that one.
Hello, everyone. My name is...
Yeah. That's somebody we already know from last year. And the topic is on-head movements in repeated 360 video quality assessment for standing and seated viewing on head-mounted displays. It's a short paper as well, and it's from Mayet Elwadi, Hans-Jürgen Zepanik, and Jan Hu. Have fun with it.
Hello, everyone. My name is Majid Elwardi. I'm doing PhD under the supervision of Professor Hans-Jürgen Zepanik at Blekinge Institute of Technology in Sweden. Today, I'm going to present our short paper with the title on head movements in repeated 360-degree video quality assessment for standing and seated viewing on head-mounted displays. The outline is as follows. First, the introduction, followed by the experimental design and the experimental results, finally, conclusions. Due to the rapid development of virtual reality, it's important to understand the behavior of how users view videos on HMDs. For instance, head and body motion prediction can be used for predictive pre-rendering of videos to cope with the ultra-low latency requirements of VR mobile applications. In this paper, we investigate the influence of standing and seated viewing of 360-degree videos on HMDs regarding head movements and study the changes of viewing behavior over the time. Starting with the experimental design, 4 natural scenes of 10-second duration forming a set of 120 videos in different configurations have been used. Each participant joined 3 sessions for both standing and seated viewing as shown in figure 1. Participant 1 is marked in red and participant 2 is marked in blue. In the end, a total of 720 videos with the same set of 120 videos shown in each session, but in random order. Moving to the experimental results, the histograms of the head rotations for standing and seated viewing were obtained for the 3 dimensions of rotational movements. Starting with the yaw, figure 2 shows the relative frequency of the yaw angle for each session and participant for standing and seated viewing. The 2 participants have rather different viewing behavior, which are kept consistent through the 3 sessions. On the other hand, for seated viewing, both participants show similar exploration behavior for a limited range. Figure 3 depicts the relative frequency of the pitch angles. The histograms show that the exploration of the videos doesn't span over the entire pitch range, but it rather focuses on an area around the equator of 0 degree for both participants throughout all the 3 sessions. Similar to yaw, both participants have their own typical exploration behavior which remain throughout the standing and seated viewing sessions. Figure 4 presents the histograms of the roll angle. These histograms are narrow for both participants throughout the 3 sessions for standing and seated viewing. A more distinct feature that differentiates the 2 participants is the shift of the center of the histograms. For participant 1, the head on the average is tilted more to the left, while on the participant 2, more to the right. Moving to the head speed quantifies how fast the participants move the head while exploring a virtual reality scene. Head speed was calculated from the head rotation traces for yaw, pitch, and roll in degrees per second, as shown in Table 1. Rotation around the yaw axis is performed with significantly higher speed compared to pitch and roll, especially for standing viewing where participants are not constrained to a fixed chair. Head turns represent sudden head rotations by taking the difference between 2 rotational points on 2 consecutive discrete time instances. Table 2 shows the number of head turns for yaw and pitch for standing and seated viewing for the respective sessions based on the following expressions. Participant 2 produced a significantly higher number of head turns compared to participant 1 for standing viewing, but also slows down for seated viewing. Head trajectories were recorded in all sessions carrying information about the rotational and translational head movements. Figure 5 shows the polar plot of the top view of the experimental setup revealing the yaw angle and radius of the movements. For standing viewing, participant 1 head rotational movements are similar for all 3 sessions, while the translation movements are rather limited for session 1. On the other hand, participant 2 shows a much wider exploration. In contrast to the large rotational and translation movements for standing viewing, the head trajectories for seated viewing are similar focus for both participants throughout all sessions. To conclude, each participant have their own distinct exploration behavior for standing viewing, which becomes less different among the participants for seated viewing. Head movements are higher in standing compared to seated viewing with a higher rotation in yaw followed by pitch and then roll. A tendency of reduced rotational exploration for the 360 videos is observed in the repetitions for standing and seated viewing. Finally, increased translational head movements appear to encourage in the repetitions for standing viewing. This is the acknowledgement. This work has been supported in part by the Acknowledge Foundation in Sweden throughout the VIATEC project. Thank you for listening. Please contact me if you have any questions.
Yeah, thank you.
Right. So we have only a few questions. Do you just want to unmute yourself and answer them directly in whatever order? That should be the easiest.
Yes, okay. Yeah. So I think the first question, how did you actually measure the head rotation, including or not including rotation of the upper body? So I think for the first part, I think we have the values from the HMD, and we use the Euler angles in order to get the rotations of the yaw, pitch, and roll. including or not including rotation of upper body. I think it's just about the head rotation. It's not accurate. Like we don't have, if I understood correctly, like you cannot, if you fix your face and you move your body somehow, some angles that will not be measured. So it's about the rotations comes from the head mounted display. Were participants seated on a yeah, they were sitting in a stationary chair. It's not a rotational one, so it was a fixed chair. So they just sit, see one part, and that's all. And for the seated standing scenario, it's just free, like they stand free, like they can do any task, like they can just rotate whatever they want. Is there a quantitative model of these results that can be used for prediction? Well, I mean, this is a nice question. I mean, this we found a paper at some like they found like they could correlate or check which participant who is related to which head rotations. So, and they said that it could be like the fingerprint of each participant. So we didn't do any quantitative model for that, and it requires, I think, more participants in order to come up with some modeling for that. But I think there are some work on that. Yes. So do we have? I think that's all. And I don't know if you have any more questions or.
Yeah, if you have any more questions, feel free to just unmute yourself if you have any. And if not, you can always add questions later or put them on Discord or contact the authors directly, of course.
Yeah.
All right.
Should we go to the next one? Okay. I can at least pronounce the names of these authors.
Hello, my name is.
I think that should be doable. So the next one is an invite talk again. And the topic is how to take a break from embodied locomotion interfaces. The work was done by Carlo Fleming and Daniel Zilasco. Have fun.
Hello, my name is Carlo Fleming. I'm a student at Trier University. I'm working with Daniel Zilasco on the project How to Take a Break from Embodied Locomotion Interfaces. This will also be my master thesis. First of all, I want to talk about our motivation for the project, and I will also describe our main problem. Then I will discuss about the possible solution for the problem, and I will tell you about our current study design. The most common locomotion technique used for VR is still the controller. Either it used for teleportation via pointing or continuous movement via joystick. Other techniques are not matured enough yet, like embodied interfaces, who still face some difficulties in robustness and calibration. When we talk about embodied interfaces, we think particularly about leaning, and when we talk about leaning, we are preferring seated leaning because we experience some accuracy advantages compared to leaning while standing, and also there are less chances to fall from a chair overall. I would like to explain the general idea for leaning input for those who are not familiar with it. Leaning defines a null position where you don't move in-game as long as you don't deviate from that point. This is usually a point that is defined when you sit in a comfy and straight position. If you tilt your body in any direction, you will move in-game in that direction. Basically, when leaning your body, you're representing a kind of human joystick. A joystick itself only manipulates the in-game values when it's pressed, which would be the movement at this example. If you don't want to continue our movement, we just let go of the joystick. This is a pretty common technique for a joystick, and the joystick on the controller got only one task, which is to define the locomotion. We can do other tasks with different buttons at all time. But when we think about seated leaning, we can't just release a button to stop movement updates. The problem that occurs with this embodied locomotion technique is that if you, for example, want to pick up items that are not easily to reach, then usually we automatically adjust our body position, which will occur in in-game locomotion. Same happens when looking around or underneath something. our body will need to change position, which would occur in locomotion according to the implementation of leaning. With these unintentional changes in our body position, we override the potential functionality of the embodied locomotion. What we would need to solve that problem is a kind of stock mechanism that pauses any movement updates in-game when needed. In this way, we can change our body position for different tasks. The question is now, how do we pause? How does the best mechanism look like? If there are good metaphors, which metaphors are most intuitive and for which cases would they work? Obvious solution would be to take a controller button as the braking method. But the first question would be how to use that button. Either we press a button to brake, similar to braking a car or a bike. In other cases, it could be better to work against that metaphor and release a button to brake and hold it to activate the embodied locomotion. This could be a better solution for an application where we would stand still most of the time. Or do we just say, use the button as a toggle to change the state of on and off? But then we would need the feedback of the state which is currently locked because we could forget it. Is there a good solution or does it depend on the application? Furthermore, do we limit the leaning method by using controller button? Normally we don't need a button for leaning and we could work controllerless, else we would need a controller and lose a key that we could have used for a different task. So are there even other solutions or other metaphors which may not even require a controller? We think there are and we are working on it. Our current study design will include two basic tasks that will encourage body movement changes. One of them will be controllerless and one will require the use of a controller. As brake methods, we thought of 6 different ones, whereas 2 using controller inputs and 4 won't. If you are interested to collaborate or participate in our study and have access to Oculus Quest or Oculus Quest 2, contact us. Thank you.
Thank you, Carlo. Are there any questions?
I think there are a few on the sticky boards and there might be more coming up. Do you just want to answer directly?
I can try. Which are these buttonless metaphors? Currently, we are still working on every method, so we can't say for sure how each method will look like. And also we thought of giving all participants the same information at the start of the study, so nobody has any advantages beforehand. And we thought because some of you could be participants, I shouldn't say explicit how every method will work or could work at the end. We also thought about voice-activated methods. This was the second question.
Yeah, when you want to know, participate in the study. That's the method.
All right. Are there any additional questions? If not, shall we just move ahead? Oh no, there's one coming. Can you elaborate on? You can also directly unmute yourself.
Yeah, sorry, that's a good idea. Can you elaborate on like stopping after you are like moving at a certain speed? Like, do you think people would use the button, or do you think like how do you balance your velocity? Let's say.
You mean if people would use a button to stop from high speed?
Or, I mean, like, would it be feeling natural if you were like leaning forward and then if you release the button, if you just stop at that instant, would it feel natural? Or
I guess people would only stop when they would like to stop, and I think they would be prepared of somehow stopping that they are stopping. So of course it wouldn't feel natural, but if they wish to stop, they should be able to stop.
So
I don't know if that answers the question.
when I do get the question correctly, it's referring to the problem when you are full speed, you're leaning forward, for instance, and then you stop, you brake. If that might feel strange, or even when you release it again, if that's strange. Is that going into the direction of the question?
Yes, like how do you plan stopping? Like, do you lean backwards, and does that stop you at that instance as well, or like how do you control acceleration?
When you are using a button, you're just braking when you use it. It's overwriting the interface. So when you are leaning front, of course, some people will prefer going to a zero position then brake, but others will prefer braking just when they are full speed. And that can, of course, feel strange when you release it, for instance, but that's part of the work.
Okay, thank you.
Yeah, I think that somehow also finishes our time for questions. So yeah, when you have more, add them, and Carlo and I will come back and try to answer them. Okay, which directly brings us to our last talk. I'm losing control over Miro. So, which is a short paper again. It's the Bayesian causal inference of body shop ownership model, using InVR and plausible parameter choices. This work is from Moritz Schubert and Dominic M. Enderes.
Hello, my name is Moritz Schubert, and welcome to my talk, The BCI Bow Model Uses InVR and Parameter Choices. Due to time constraints, I'll be giving a highly simplified explanation of the model. The BCI Bow model tries to model body ownership. Body ownership is the experience of a body as one's own. It's highly relevant to the field of VR, because in many VR scenarios, the user inhabits a virtual avatar and is supposed to feel ownership over said avatar. BCI Bow stands for Bayesian Causal Inference of Body Ownership Model. Bayesian refers to Bayesian statistics, which is a mathematically rigorous way of updating existing knowledge through data. Causal inference is a process of inferring the causes of events based on their effects. We as humans experience these effects in the form of sensory input. Bayesian causal inference models pose that whenever we experience two different types of sensory input at the same time, we tend to conclude that all of this sensory input was caused by a single entity. And finally, body ownership we've already talked about. This is a graphical representation of the model. I should stress that it was formulated for ownership over a single hand, but can, in principle, be extended towards the whole body. When inhabiting an avatar in VR, we have two relevant types of sensory input: the visual input from the virtual avatar and the proprioceptive input from our real body. Proprioception refers to our inherent sense of the position of our body parts. According to the BCI Bow model, if a person maps their proprioceptive input onto an artificial object, such as a virtual avatar, they begin experiencing ownership over said object. But how does this remapping come about? Upon being faced with said visual and proprioceptive input, the user could come to two different conclusions. For one, they could believe there are two separate causes, meaning that the virtual body causes the visual input and the real body causes the proprioceptive input. In this case, they would think of the virtual body as a sort of visual overlay above their real body and not experience ownership over it. The alternative conclusion is that there is a common cause to the visual and proprioceptive input. In this case, the user maps the proprioceptive input onto the visual input and begins experiencing the virtual body as their own body. If the visual and proprioceptive input are in synchrony with each other, this is strong evidence for a common cause. This is the case when the motion capture data is displayed in VR with minimal lag. It is important to note here that vision has a much higher precision than proprioception. This is why the user maps proprioception onto vision and not the other way around. They trust their vision more than their proprioception when trying to decide whether the virtual or real body is the common cause. Whenever we want to update our knowledge using Bayesian statistics, we first have to codify said knowledge in the form of a prior, which is a probability distribution over the quantity of interest. In the case of the BCI-Bow model, one of the priors is the participant's estimation for the location of their body before putting on the HMD. The model's authors used a normal distribution with a, quote, very large standard deviation for this prior. Their aim was to flatten the normal distribution to the point that it resembled a uniform distribution, meaning they wanted to mathematically represent the presumption that the participant has no idea where their body could be at the beginning of the experiment. The standard deviation they used for the normal distribution is 10 to the power of 29 kilometers, an unimaginably large number. To put it into perspective, this is larger than the estimated diameter of the observable universe. Admittedly, with this astronomically wide prior, the model works quite well when predicting results that have been observed in previous experiments. But since we are not only trying to predict, but also explain human behavior here, I think we should choose parameter settings that are plausible within the context of the human mind. Trying to modify the model so that it fulfills both of these objectives is the main focus of my current research. For now, I want to conclude by saying that while I think that the BCI-Bow model is a valuable first step towards an algorithmic explanation of embodiment, it is psychologically implausible in its current form and in need of revision. Thank you for your attention.
Yeah, thank you, Moritz.
So I can try to answer the question that's there.
Yeah.
Can you hear me?
Yes, thanks, Dominic. That sounds a lot better.
Yes. So how do we think we could apply this model? Well, one of the things that we would like to be able to do is predict when people feel ownership over a virtual body, and in particular to give us the chance to intervene when this ownership goes away, or to modify this ownership in order to, for example, test how this sense differs between different participants, or even with between people with certain psychological conditions such as schizophrenia or autism. And as far as the creation of application is concerned, you could, for example, on the one hand, you can just try to improve the experience of the average user who's using like a consumer VR in order to experience ownership over the body in the context of a game. But on the other hand, it might also be useful as a training application for people who for some reason have lost this sense of ownership and need to learn how to get it back. Okay, next. Have you considered audio additionally to proprioception and vision? Yes, we've thought about this. What we have tried in the past is haptics, like when you create VRs where you can actually touch stuff. So have like surrogate objects in the real world that can be touched in the VR, but we haven't really found a good way of including audio, even though from the modeling perspective, it would just be another sensory signal that can be added to this model. In your model, visual motor seems to be the most important parameter. How do the participants see themselves? Well, they see themselves from a first-person perspective. They're kind of looking down on their avatar. Is that the question you wanted to you wanted to ask? Okay, and super interesting to involve transhumanist people who modify their bodies. Yes, that's quite true. I would agree that it would be interesting to test people with modified bodies, or to give even normal humans body parts that they usually don't have, and see if they can start to own that.
All right.
Okay. Yeah.
Well, thanks everybody for all these interesting talks and questions and so on. So big round of applause to all the presenters and questions, virtual applause, wave your virtual hands. Daniel, should I take over with screen sharing?
Yes, sure.
For the next part. Okay, let's try that. All right, so you should be seeing the mirror board again. Can somebody confirm, please?
Yes. Okay,
good. Yeah, there's 3 screens, so I just want to make sure I'm seeing the right thing. So just want to give a bit of a big picture where we are right now. So what we'll do next for the next 10 minutes or so is talk about the different breakout rooms and then have a break. So for about half an hour or so, depending on timing. What we'll do afterwards is basically spend almost an hour, I think, in breakout rooms. And then take some time for each breakout room to present what they'll do, and then we'll have some closing session, we'll ask for some feedback, and we decided to try and do a final social half an hour, whatever much time we have. And we're not relying on the IEEE VR Zoom server, so basically this is open-ended. So let's go in there where we are right now. So basically, before the break, what we wanted to do is ask you to think about the different kinds of topics you might be interested in answering. So our suggestion would be to have relatively small breakout groups, so 3 to 5, maybe max of 6 people. So you really have time to work together and to think about it. So basically after the break, you'll be in breakout groups for about an hour and us to work together on different topics. And we suggested a few different ones here. These are links to Google Docs, where we have 3 suggestions so far. So one was basically what are key challenges and opportunities of embodiment and virtuality where you can't walk naturally, or even you have to sit. Keep in mind, these are not locked because otherwise they could not be edited. So please don't move them around, otherwise it'll be hard to keep track. Second topic we thought could be interesting is to basically talk about when to sit or not to sit. So when does it really make sense to sit, standing, walking, swimming, running, jumping, whatever. So really what posture really makes the most sense and why. And the third topic we thought we'd like to get into is really what specifically is sitting and missing in virtual reality when you're sitting, or basically when you can't physically move around. And then there's lots of other topics that we could be doing. So, oops. So what I want to do over the next few minutes is basically see who might be interested in what topics. And keep in mind, we also had additional topics coming up from our survey. I just put them in here, like not getting sick, transitions between walking, running, and other things. So basically any topic that are roughly in the scope of SeatedVR and embodiment could be a good one.
Bernie, perhaps useful to say that we can also make 2 breakout rooms with the same topic. So it's not like
absolutely.
We want to stick to the 5 or 6 people and then the room is full basically. So if we have more people interested, we can break it up.
Yeah, exactly. So yeah, if everybody is interested in the same topic, then we could have a lot of rooms for that topic. So I guess the first question is, are there any other topics you guys would be interested in discussing? And I think the easiest might just be to unmute yourselves, or you can also put it on a sticky here if you have any additional thoughts that any topics you'd like to cover. seems like people tend to like these topics, which is good. If anything comes up, let us know. So what we could do next is then maybe, so we'd like to see who's interested in what kind of topic. So if you could just, the easiest might just be to grab one of these green stickies, put your name on it. Maybe I'll make them a bit larger, and then move them on top of the breakout room you're interested in. And then we just duplicate the rooms as we go. Because we should also put ourselves in. Yeah, so take a moment, put your name there. And if you just want to listen in but not fully participate in this, you can also just join the session during the presentation later, so that we have the schedule basically up there. So basically, if you're more interested in just listening to the results, then I'll be back at 1950, that's 7:50 in Portugal time zone. But for those interested, I think it would be good to, if you could put your sticky in, and we have a few already. And if there's any additional topics, then let us know. Okay. So far, it looks like we have a few small groups. That is totally fine, where we can discuss in. Take your time. You can think a bit more about it. If you have any additional topics, you can also bring it up right after the break. But just make sure your name is there listed. So I'd like to basically show us, okay, so what we'll do mostly after the break is really go into these. So these are links to actual Google Docs. If you double click on it, it opens it up in Miro, but there you don't have the full editing rights. If you basically click on that link here where it says source, oops, so you need to click here and then source, then it actually opens up the actual Google Doc, which we figured might be more powerful. So you can basically take notes there. And what we'll ask people then after they are in breakout rooms, briefly scroll to that, is basically present their work. Depending on how many groups we have different amounts of time basically. And then, so when you go into breakout groups, make sure there's somebody there that will talk about the results of the discussion afterwards, so we can bring it together. And feel free to use the Miro board for any kind of visuals, or directly do everything in the Google Doc, or if you want to create something else and link to that, that also is totally fine. I think that's the main part so far. So here we go. Any other questions before we go into our break? Okay, good. Then let's introduce our break. So what we wanted to do is at least try and do something that's a bit more similar to a natural conference where you can just kind of talk and chat with people. So for this part, we won't be using Zoom or Miro. We're using wonder.me. So if you click on that link, just kind of just screen share it. Basically, you get asked to select, okay, which camera do you want to use, which microphone. You can take a picture, smile, put your name here. And then there's a room here. Daniel and Ernst, if you could join as well, and we can quickly show. And the idea is basically, this is the space, you can zoom in and out. And for example, if I move myself basically here, oops, then, oops, where's Daniel? We end up in the same room, so we can actually talk in there. So it's kind of like a real room. As soon as you're close enough, you can actually have a conversation. If you want to get out, you just get out and you lose the connection.
Yeah, you might have to disable your camera in Zoom so it can be accessed in the other.
Oh yeah, for sure. And
then
so this way, yeah, and this way you can basically just join different people. All right, so I suggest we do that. And, okay, sorry, let me mute my camera here. Okay, so hope. All right, so we'll do this. Okay, I think that right now there might be too much sound feedback. So we'll do this for the next about 20 minutes. So get your coffee, get whatever you need, and we'll see you all back later. And this socializing link is open to anybody, so whether you're here or not. And, yeah, and enjoy and see you there. All right, so what we wanted to do for the next about 20 minutes is give the different teams a chance to present what they did, and then do a short question answer. So if during the presentation you have any questions on, just use the sticky notes below here. That might just be the easiest. Can somebody confirm that you guys see my screen sharing Miro board?
Yes.
Okay, good. And then we'll, as usual, try to time box it a little bit. So but I think so far we're roughly good in terms of timing. So we have scheduled about 20, 25 minutes or so for this part. So maybe you can take 3 to 5 minutes to present for the different teams, and then discuss each group for another 3 to 5 minutes, and then move on. So one thing I could do is basically just go directly to the document, if I can find it, in the breakout room discussion here. And Dominic kindly offered to talk about it. And so I'll try and keep up with scrolling through what we have while Dominic will talk about it.
So yeah, let me know when to start now.
Yes, let's go for it.
Okay, so in our breakout room, what we discussed are the challenges and opportunities of embodiment in VR when you can't walk, or even have to sit, or maybe even have to lie down, depending on the scenario. One of the challenges that came up early on, I'm first going to talk about the challenges, then the opportunities, is that you need a way of intuitively interact with the VR so you can still move. We're used to having our bodies move because we produce walking output, and this is now no longer the case. And this, oops.
Sorry, just trying to show this at the same time.
Yeah, and this is interlinked with the third point, namely, can we even hope for an embodiment while moving through space when we can't actually physically move, because it's kind of known from sensory motor control research that it's the expectation of the sensory consequences of your own motor signals that you are predicting, and that gives you the feeling of inhabiting the body that you are moving. And that was also the fourth point here. It's well known in VR research that there are such phenomena as simulator sickness, namely that you have a mismatch between your motor and your vestibular signals that can cause a prediction error which might make you seasick. What also has to be remapped when you are moving with some other device is your agency. But that with a wee bit of training is usually easy enough, and most users nowadays have ample experience with computer games and with computers in general, so we don't see a big problem there. What are the opportunities of embodiment in SeatedVR? Well, in contrast to full body immersive VR, it's much cheaper. You basically need an HMD and maybe a few trackers, and not like a whole body motion capture setup. It's therefore also more easily deployable and may provide an easy entrance point for new users that are trying out VR for the first time. One of the things you can also do there, because you can basically remain in your seat, is you can try out a new body that you don't know how to control yet, that may be useful for rehabilitation, like after a stroke or after you've lost a limb or stuff like that. It could also be quite useful for training social interactions for people who have deficits in that realm. If we wanted to build cyborgs, then this would also be a great starting point, and it's obviously useful in motor control research. We can try out what it would be like if we had like extra limbs, or if our muscles were wired to our limbs in a way very different from what they actually are. Also, if you don't move your actual body, if you're sitting in a chair, then you're expecting less sensory signals than if you were actually moving your whole body, and therefore it might actually be easier in SeatedVR to induce embodiment than it would be in full body VR. And that links to the next point, which is the fluidity. We can basically we don't have to embody the whole body. We can only embody parts of it. We can choose what we would like to embody. We can even be completely disembodied, which may be interesting for some other applications, like when it's being used in therapy, or for people with fear of death and so on. And the other points really all just relate to that. You can transform yourself into any body that you can conceivably program. You can even be completely non-human, and you might also be able to do things that you could not do so easily in real life, like embody many entities at once. And that means that you can also do things like psychedelic research, and VR has of course been used for things like that, like for the creation of out-of-body experiences and astral projection and so on, but that really links back to the fluidity points. Yeah, the next point about does it enable us to move around more easily? Well, yes, in particular, it allows us to move in ways that we could never move around in our normal lives. And it might also be able to help people who can't move to actually move in an embodied body. Okay, then I'll stop talking here.
Yeah, thanks so much, Dominic. Any questions? Or maybe just try and time box it a little bit. Any suggestions, anything we're missing, any opportunities? So we got really interested, especially in the opportunities, because that's something that's less talked about, of the lack of embodiment. Any questions? there's no questions, then let's move on with the next one, and then just we have a bit more time with our discussions. All right, so the next group was this one here. I'm just going to open it directly there. Is it okay if I screen share the document? So who wants to present from the room 2?
I'll present. So, so the question that we had is to sit or to not to sit. And I think the
sorry, let me just
time's
reset
up.
the time.
All right,
Time's
thanks
up.
everybody.
Yeah, okay, I'll give you 5 minutes just in the background.
My TED talk.
Great, sorry, Kent.
No, okay. So to sit or to not to sit, and I think the immediate answer is that, well, it really depends on the context. And so we did a couple of things after that, which was to kind of go through some of the different, contexts, but also this is just a conceptual framework that I've put out in terms of how to think about the nested dimension of the different contexts. So you have at the core, well, the most highest level, you have the culture, the laws, economy, and then eventually design guidelines, user experience, app code, operating system, hardware, and tech. Well, this issue is like this intersection between the technology of what you can do with the technology, but also the user experience of what it feels like to either stand or sit. And that's also within the context as to what kind of extra devices that individuals want to buy. So like people in VR chat, if they want to have full body tracking, they spend an extra $100, and then they are able to have their full body, and then they have these extra affordances of having higher virtual body ownership illusion, or they can actually communicate their body language to other people more, or they could start to go to virtual raves. So there's different behaviors that we are seeing, at least in the market, where people have decided that there's a demand for higher fidelity of these things. But at the end of the day, it also comes down to personal preference around whatever your mood is in the moment. And then you kind of have to go through your own trade-offs between, okay, I'm going to do this experience right now. I'm in VR chat for the next, 5 hours. Well, I'm going to sit down because I don't need to have extra level of communicating my body language. Or, maybe you really want to have that extra degree of embodiment in Half-Life Alyx. So you decide to stand during that game because you want to feel that extra levels of immersion and presence. So there was in the Miro board, there was the big grid and trade-offs. And so when we were looking at throughout the course of the discussion to stand or sit, we were like, well, that's a good starting place to kind of just pull in all these things that are already listed on that matrix. I went through and just started to categorize them into different potential equivalence classes. And an equivalence class could be all of these things are perhaps either competing against each other within each of like embodied presence. Like you want to have more comfort, and in order to have more comfort, you sit down, but then you have less embodied presence or embodied immersion. And so from there, we just kind of went through the discussion and brought up other things. Some things you could measure, and some things I think are not really measurable or haven't been measured or haven't been established that there's a difference. Anything with a question mark, I think is, is there differences in your spatial memory when you're standing and moving around a space versus sitting? I think there has been some research in that. Or difference in proxemics, meaning that the way that you have your social interactions, are there different physiological differences when someone invades your social space when you're sitting down versus when you're standing up? And so generally, a lot of this stuff that we have in there was listed already. And I think there's other kind of interesting things that came up that weren't on that list, were say, what about sensory substitution techniques and trying to invoke different multimodal illusions, or you start to have these wearables with biofeedback, like Facebook talked about having their Control Labs watch. And when you are touching something, then you're able to, kind of stimulate your finger touching something, but it's only like vibrating your wrist. So to what degrees can you do the type of sensory substitution techniques? And are there differences between whether or not you're mentally, your experience, your phenomenological difference, the qualitative difference between whether or not you feel like you're being tricked more or less with some of these different techniques, whether you're standing or sitting. So that could be a whole line of potential research. Yeah, so I think that was the overall gist. I'd say I'd call out here the technical context, where a lot of these here are phenomenological, like your own direct experience of what some of these things are or what's been able to be established. But there's other things that are like more like the tracking, you know, whether or not the tracking technology can do more or less things, whether or not you're standing or sitting, or the actual space that you have available, sort of the outside context above and beyond what you're doing. But I think just to go back to the context, you know, like there's being at work and whether or not there's going to be certain contexts where you need to be standing or need to be, you know, kind of already in that context. And so some of the to stand or sit situations comes down to what the existing context is. And then from there, it's, I guess, to what degree you're kind of trading off all these other dimensions. That's it. Yeah.
You're muted, Bernie.
Yeah, you're.
Sorry. Okay, thanks. Yeah, so thanks a lot. If we need, I think we have another few minutes if there's anything else to report, but I think there was already a lot of really interesting thoughts and insights.
Mm.
Does anybody have any questions on that? Well, maybe you can just move on with the next presentation then.
I think we can see the general picture after the third one.
Yeah, so. Yeah, that sounds good. All right, so let's go for the next one. And let me restart a timer just so we have something roughly in the background.
Okay. I think there's a better structured summary in the next page.
Yes, just go exactly. Yeah.
Okay, so we had a lot of interesting discussion on different aspects. A lot of it is about multisensory experience of walking. And so we started by, by grouping items and ideas, basically. There's a lot of sensations. So for example, the lack of sense of turning, rotation while you're sitting. And how is the experience of turning when you're in a wheelchair, for example. So for a wheelchair user, the experience of moving is different both in real life to people not on wheelchair. And so their expectation of what it means to move in VR is slightly different. And so then there's physical sensations, so the lack of the weight of the body, the hands moving, the clothes on the body. How do they feel when while you're working or while you're sitting? Similar things for the shoes, different types of shoes and how it feels when you're working, but it's likely that you don't feel much difference if you're sitting, basically. And we had a lot of discussion about the gravity, the sensation of gravity while working, and also the balance of the body. So not only the head up and down, but also how it's likely to have variation of balance while you're working. So you don't just walk kind of straight and stable the whole time. Multisensory sensations like air, the feeling of air, or the sound of the air in your ears while you're jogging, for example. There was some discussion on motion sickness, how the conflicts coming from different stimuli can generate motion sickness while seated, but not necessarily while working. And we had some research questions. So for example, can you introduce unbalance on a chair instead of a rigid surface, for example, which we discussed some previous research on moving chairs that rotates. And then also we focused on posture again. So for example, some sport movement like jumping, for example, or doing specific types of movement, kneeling, and how to design them if you're sitting. We had a really interesting talk about going up and down stairs, for example, and how we make feel for people with different bodies. So, for example, different vestibular cues are likely to have a strong effect. and the sensory conflicts in seated navigation and how they differ from ground surface. And then, yeah, some in terms of body response. So the no feeling of being exhausted or hard breathing or feeling tired in the legs, for example, stress relief. And also we were wondering ways to recreate this sort of physical sensation of being exhausted. So muscle pain, for example. And we discussed some interesting research that has been done with air pressure in wearables. So where there's, for example, wearables where there are a lot of air pockets that inflates and deflate to recreate the force pressure in different areas of the body. And I think that's pretty much it, unless my other group mates wants to add something.
Nice summary, thanks.
Yeah, cool, thanks. Excellent. So lots of really good examples. Again, on Miro, so for those of you who haven't used Miro much, so you can link in Google Docs and so on. I might need to update this so it reflects the latest version. Ernst, do you want to lead the next discussion?
Yes, what I would like to do actually right now is to see if we see some synergies between the three groups actually, because I think there are some topics that actually overlap. Oh, my time is up. Okay, that's it.
in case you were wondering.
So I was wondering indeed if we take 1 minute time to see if there are any topics in the three groups that that are really much overlapping, where we have different views on actually the same topic. And secondly, actually, if there are, but that's slightly difficult perhaps right now in a very short time, if there are any specific questions that many people are actually interested in, perhaps also questions that you've heard from other groups that might need some follow-up, right? So we tried to come up with some research questions. I mean, they were not really research questions for now, but I think they could be turned into research questions. So the second thing would be, okay, can we, from the current topics that we have identified, actually come up with some topics that people would be interested in working on together? So perhaps I'm not sure. So we didn't plan for that right now. So I don't think we can do the voting again for the final ones, right? Can we?
What do you want to vote on?
No, if we use the post-its below the documents, can we vote on that one after one?
Yes, we could do voting if people. The question is, what do you want to ask people to put on the stickies?
What I would like to do right now is if there are any overcoupling topics taken from all the three groups that actually many people found interesting, so that we can afterwards just do a vote on those topics and see if there are any common interests that really pop out here. Right. So for now, I would like to ask the people actually to just go into the sticky notes that are below the different documents and jot down any ideas also from the other ones that you're really interested in that could also be overcoupling ideas from the three different groups, and then we'll just take it up from there in the voting.
Okay, I'll set up the voting, so you can just basically add any sticky notes here on this one here, the one I'm sharing.
Does it when we are looking for common interests, does it make sense to add names to whatever you come up with, so we can find it back? Because I think the sticky notes are not related to creators or the one who
No. That's a good idea, actually, Daniel. Let's put if you put a sticky note, just put your first name below it.
So, yeah, when you put anything in where you think, is there somebody else interested in that? You want to find me back, or you want to find me, redirect me, then put your name, just put your name in that, so the others can find you.
Of course, if somebody already has a sticky note that you're interested in, you can already put your name next to it. But.
So I think I'll probably open up the voting session so you can start reading through the different votes and probably still start typing, if that makes sense.
I think probably.
Or wait another minute?
Yeah, let's wait another minute, I think.
Okay, good.
Perhaps somebody.
Yeah, yeah, sure. All right. Who wants a bit more time to write down any ideas? Otherwise, I would basically ask, so Ernst, how do you want to do the voting? Basically voting on topics people are interested in?
Yeah, something like that. So I would,
sounds good.
Yep.
Let's do that. So hope this should work. So you should be able to see the different ones. Right, another 20 seconds to vote.
Oh.
Okay, so looks like we have a few different ones that people are extremely interested in. How to better stimulate a sense of turning without turning by Atta. Also, does it really feel like to embody a different person entity and how we could research that? There's some interest in exertion and the sensation of actually walking while seated and the sensation of seated while walking. So both ways.
That's a very nice one.
Yes, very symmetric. Can we take advantage of this embodiment in some kind of way? Could we use this embodiment to simulate different types of bodies?
It's actually the same as yours, I think, Bernie.
Yeah, I think there's a bit of overlap.
Similar to you, yeah.
Plausibility of different kinds of movements, whether it's sitting actually and how it might affect the ability to move around. Comparing different walking surfaces. Daniel, some people are really interested in Daniel, which is good.
Yeah.
So also how to fill, how to fill the gap between skill settings. So Daniel, this is great. All right.
Yeah, when you're really interested in that stuff, because there are much more votes than names, put your name into it, because otherwise you will not find each other. Maybe we have some time later in the socializing event.
That was actually the idea, that we'll have some topics here that people might be interested in talking about actually in the social room, which will soon take place actually. So
still grab a sticky and put your name there.
Exactly. So if you're interested in a topic, just add your name below it. That's also nice for documentation. Let's put it like that. So it's easy to contact people afterwards.
And thanks, Kent. I think you are already were faster than me in putting the results here next to it, which is great.
Excellent. Okay, I think I would like to leave it to that, because I think if we want to discuss about the topics goes too far right now, which we can easily do in Wonder Me afterwards. So perhaps we'll just move on to the wrap up.
Yeah. Did we decide who's going to do that?
I don't think so.
Okay, so one of the things we definitely wanted to hear your feedback on. So first of all, thanks so much for joining and for participating in this. And we're basically trying to tweak and trying to see how we can really make this work online. And what I'd like to do is basically ask you to give us some feedback on the workshop. It can be very simple, up, down, or something, but we'd really be interested in seeing, okay, what did you really enjoy about this workshop? Is there anything that we can improve for the workshop or similar workshops in the future? And then also, do you have any suggestions for future workshops? Any interesting directions? Could be related to SeatedVR or just anything else that came up during the discussions. So any thoughts on that would be super highly appreciated. And yeah, let's maybe start with that for a moment. And I can give you some background music.
Yay.
Ladies and gentlemen, as you know, we have something special down here at Birdland this evening.
Good old US3.
Yeah, and we are really interested in your feedback here. And also if you want to be involved or whatever, because already this year we talked a lot about the future directions, and if there are future directions, if there's a SeatedVR workshop again, or should it be something different. So I think the crucial point for this discussion is, do you want to see another one? Do you want to see one that's different than this one? Do you want to have us another topic or whatever? So it's we really want to have that feedback. It's not just made up. Yeah.
Perhaps at this moment, so because it's not anonymous right now, so we'll probably just open up the Miro board for a little bit. So if you want to put your comments later on that everybody's looking what you're putting in, you can do that too, right? So yeah. I'm not sure when we want to close the editing, Bernie, on the Miro boards.
We'll leave it open for another hour or so.
Okay, so if you want to leave anonymous feedback, then
yeah, that's totally fine. I'll make it really small so you don't see who's writing what.
I had another a workshop event that I was attending at the beginning, so I came in a little late. But I will say one advantage of doing something like Miro is that it ends up being a really nice archive and documentation of a lot of the discussions that would be beneficial for people to have access to. So I understand there's some stuff in there that, you know, you're putting in your name or other personal information. So finding a balance of like, you know, what is good for the context of the event, but also what is a good archive of conversations if people want to get ramped up or go in and watch, you know, a video. I think it's a good format to be able to help archive some of these discussions and facilitate
types of experiences we could start to experiment with to broaden our normal perceptual abilities.
Yeah, I think it's working quite well, I would say. I mean, like if you embody a different gender or a different race avatar, probably you feel different if you have a strong enough embodiment. Or if you embody someone who is victim of from a different I don't know how to say that, yeah, different gender, to make it simple, and you see and you experience as a different gender like some violence or some yeah, I think it makes you more empathic through the group you don't belong to. I think this works quite well if you have strong enough embodiment.
Yeah. All right. So Yeah, as mentioned, so if you have any other suggestions, things to do, things to improve, and so on, please let us know. Just put it in there. Ernst and Daniel, I think I would suggest you just kind of close the official part and go to social space so we can chat a bit more.
Go to social space. I think that's...
Yeah,
that's
so...
smart.
Just in closing, thank you all for participating. It's been, well, not quite as nice as hanging out with you in person, but at least no jet lag, just getting up at awkward times. So thanks all for joining. Hope to see you in other space around the conference. And so basically can go back to the same wonder.me room. And as you notice, you can basically just have small conversations, chat a little bit. So it doesn't need to be in the large group. So you can do one-on-one or whatever it is you like, basically. And we can just leave that open. So I'll probably leave the Zoom room open just with screen sharing so people know where to find things. And Daniel, could you also post it on Discord so people know where to go in case you wanted to?
The WonderMe, you mean?
Yes,
Yep.
yeah.
Yes, of course.
Perfect.
I'll do in a second.
Yeah, and so yeah, thanks all for joining. I hope this was useful. Certainly enjoyed all the interesting conversations, and the links to the documents and so on will all stay up. All right, so we'll see you in a moment in wonder.me. So,
okay.
All right, so thanks everybody.
All right.
Thanks.
Thank you.
Bye.